Welcome back. The beginning of stoichiometry, mole-to-mole conversions. First thing you have to do to be able to do stoichiometry is have a balanced chemical equation. We will be given equations that you just need to balance first. So you will not have to write them from scratch. You'll just have to be given one as you see here and then balance it. So as I think about balancing this, and we're going to use this for the first 5 examples, this balanced chemical equation. I see that I have 2 nitrogens and 1 nitrogen, so I'm going to put a 2 here. So now I have 2 nitrogens, but now I have 6 hydrogens. So I'm going to put a 3 here, and this is balanced with a 1, 3, 2. Okay, so our first example, again, in order to do this, you're going to have a balanced chemical equation. So we have our balanced chemical equations here, and this is going to feel very similar to this skills we were doing with this last mole conversion unit, with the exception is that none of these problems will you be using 6.022 times 10 to the 23rd. We just don't have enough time to get that detailed. So you will only be using the periodic table number and the relationship that we're going to establish between the numbers in front of our balanced equations. So as I look at this balanced equation, I would really read this as 1 mole of N2, 3 moles of H2, and 2 moles of NH3. And these are all related to each other and can be set up as ratios. 1 mole of N2 equal to 3 moles of H2, or 3 moles of H2 equal to 1 mole of N2, and so on. 3 moles of H2 to 2 moles of NH3, 2 moles of NH3 to 1 mole of N2, and I can set those up as ratios. So you will see these ratios to allow us to switch from one part of our balanced equation, any part in there, to any other part of our balanced equation. We can switch between reactants, we can switch from reactants to products. If there was another product, we could switch between products. So you just have to be very careful to see what's given and then to go through. Now, you may see stuff that says excess reactant. You can ignore that for now. We will talk about that in notes to come. So, just like before, we're going to look for that piece that we know. So as you can see, you're looking for a number, a unit, and a chemical formula that goes with that number and unit. That's very important. We don't care about this H2. It's not with the number. It's just to complete the sentence. Okay, so we're going to take then and start with, like before, 45.0 moles of N2. Just like in the previous work, you must do grids. You must have a number, a unit, and a formula in every grid. So we know from before, if we have moles of N2, or from all the work we've done with grids or unit conversions, then we must have moles of N2 here. So I need to think about, where am I going? You'll hear me say this from time to time, especially when we're doing stoichiometry, where we're going goes on top. So we're going to look at moles to moles. What I will tell you is, as soon as you have moles in your top position, and this one starts with moles in the top position, your next step is always to mole-mole shuffle. What that means is we're going to shuffle from one part of the chemical reaction to another, and we're going to set up a mole over mole ratio. So we're going to go moles of N2 so it cancels, and moles of where we're going goes on top, and we're going to NH3. Okay, ammonia is NH3, so we're going to moles of NH3. So we don't really care about the moles part yet. We care about where the chemical is we're going. So this is the relationship that we're allowed to do, because this is what I call the mole-mole shuffle. We're shuffling from N2 to NH3 based on the relationship in the balanced chemical equation. So we're going to put how many moles there are in the balanced chemical equation. That's why it's so important that you balance the equations before you start and they're balanced correctly. So this will be 1 mole, because there's nothing here, so we know it's a 1, and then 2 moles of NH3. And then I really don't need the rest of my grid. I got a little carried away with making my line, because if you notice, let me switch back to my pen, as I cross off my units, what I have left is moles, check, and ammonia, check, and we're done. So now we're going to do that same kind of math, multiply across the top, divide by the numbers on the bottom, so 45 times 2, and I'm going to apply sig figs here. We will never use our mole-mole ratios as sig figs. Moles to moles will not be used as sig figs. So we only have 3 sig figs from 45.0, so our answer is 90.0 moles of NH3. Okay, if you need to, pause, rewind, and listen to that again. Remember that as soon as we have moles in a top position, the next grid work will be mole shuffle, moles over moles. Where we're at is on the bottom, so it cancels. Where we're going goes on top. Moles on top. Next thing is to mole shuffle. Where we're going goes on top. When I say where we're going goes on top, I'm talking about what chemical are we trying to get to goes on top. Okay, another example. Okay, we are going to start this one. I got that same balanced chemical equations. We're going to start with 32.0 moles of NH3, and we're going to start our grid. We know we have to have moles of NH3 here. Why? Because I know it cancels. I have moles in a top position, so my next grid work is going to be moles over moles, or I like to say the mole shuffle. Where we're going goes on top. We're going where? We're going to this chemical, H2. Okay, so we have mole shuffle. Why? Because we have moles on top. The next grid has to be the mole shuffle. We got to put moles of NH3 so they cancel. Where we're going goes on top, moles of H2. Now the numbers that go here have to come from the balanced equation. In your mole shuffle, every time you mole shuffle, your numbers from your mole shuffle or for your mole shuffle come from your balanced equation. So we have a 2 here and a 3 here. 2 because that's what's in front of NH3, and that's NH3 is down there, and 3 because H2 is there. Okay. So we're done. How do I know I'm done? Because we're going to work on remembering to cancel our units. And the only thing I have left is moles, check, hydrogen, check. So now we're going to multiply 32 times 3 and divide that by 2. And I can have 3 sig figs because remember, we're not going to count these because we're going to consider them exact. The only thing we can use is that. So we're going to do 48.0 moles of H2, as you saw right there. Okay, this concludes part 1. So you can either go practice part 1. Actually, we'll do that. Let me flip over screens and you're going to practice part 1. So here we have a chemical equation that I would have normally, had we been meeting face to face, given to you like this, asked you to balance it. I would have walked around the room, had you write it correctly, then I would have had you balance it, and then we would have just been practicing that skill. But because we're not face to face, I gave it to you. We need to balance it. So this is how you balance it. I also, to help speed things up, gave you the molar masses. So these numbers underneath are the molar masses. So you may want to pause the video now and write this down because you're going to need it for your practice. So take a moment, pause the video. Again, this is the balanced chemical equation we're going to use for all of the practice for the notes. And then these are the molar masses that you'll use, so you don't have to calculate those. You will be expected to calculate those items, though, molar masses, in your actual practice 1, 2, and 3. Okay, so hopefully you paused the video. If not, pause it now. Okay, welcome back. And here you are. You're going to try at least 1 or 2 of these on some scratch paper just to make sure you're getting it from that balanced equation that you saw a moment ago. And here are the answers down here. So pause and try 1 or 2 of these. Make sure you understand what you're doing. Yes, for credit, when I'm looking at it for a grade, which will start with practice number 1, which is not this set of notes, you will need to show a number, unit, and a formula in every grid to get credit, just like we've done in the past. Okay, pause the video, try 1 or 2, and then we're going to jump back to notes. Okay, we're back at notes. So now we're going to go to example 3, mole to mass conversions. So here we have that same balanced equation, and we're going to start with the same kind of start. So we're going to look at what are we given to start with? 600.0 moles of NH3. Now I have moles on top, so I know as soon as I have moles on top on all of these examples I'm going to do with you, as soon as moles are on top, you're going to put mole shuffle. So moles of NH3 goes on the bottom. Why? So it cancels. Where we're going goes on top. Remember in our mole shuffle, where we're going goes on top. And I looked up to here to see the chemical we were going to was N2. So that's why I knew it went on top. I look at my balanced equations. I have 2 moles of NH3, see the 2 in front, and 1 mole of N2, see the 1 in front. So now moles of NH3 cancel, so we're in N2, so we got 1 check, but we're not to grams yet, so we got to do more grid work. So now we get to use the periodic table number. We know that we're going to have moles of N2 here, and we know from the periodic table number, or the molar mass, for every 1 mole of anything, it's equal to its periodic table number. So we're going to take nitrogen twice, so 1401 times 2, which is 28.02 grams of N2. Okay, and we're going to try that calculation now. Before I do that, I want to just show you that moles of N2 cancel with moles of N2. So now you're canceling not only the unit, but you must actually cancel the unit, and the chemical formula must be an exact match to cancel. So moles of NH3 cancel with moles of NH3, moles of N2 cancel with moles of N2, and I have 28.02 grams of nitrogen from the periodic table. So we're going to multiply 600.0 times 28.02 and hit equals, and then divide by 2. Remember that we're going to can't use those. So we're not going to use this one. We're going to use the 2802 and the 600.0. We know we need 4 sig figs. So 8406 grams of N2 would be my answer. Another example here. We're going to do number 4 together. So 3.500 moles of H2. I have moles on top. So my next grid is to do moles of H2. Where I'm going goes on top. Where am I going chemically? To NH3. You're just going to have to look for the question word. So I'm going to NH3. So mole shuffle. Why? Because I have moles on top. I have 3 moles here, and I'm going to 2 moles up there. Got that 3 from here. Got this 2 because of that. Mole shuffle always has to come from the balanced equation. So moles of H2 are gone, and we have now the right chemical, right? But we don't have the right unit. We need grams, so we got to do some more work. So I know to cancel, I have to have moles of NH3 here. I know for every 1 mole of NH3, got to figure out the periodic table number. So I'm going to take 3 hydrogens at 303, altogether 303. 101 times 3 is 303 plus 14.01, and I get 17.04 grams of NH3. So moles of NH3 cancel with moles of NH3. And I have left grams of NH3. We should get that answer. We'll check it on my calculator, make sure I didn't do anything weird while I'm presenting. Multiplying 3.500 times 2 times 1704, hitting equals, dividing by 3, and I get my 3976 grams of NH3. If you want to, try this one, but I'm going to give you a set to practice here in just a moment. So we're going to flip over to the other video, and our other screen that I have set up, and we're going to do this one. So pick any 1 or 2 of these for your personal practice and try to get the correct answer. If you're struggling, please reach out to me. I have found that a conference call is best. We can schedule a 10 or 15, maybe longer, conference call, or you can email your work and I can try to help you via email response. But often it's much quicker if we can just touch base on a conference call. You don't even have to show your beautiful faces, although I really enjoy seeing you, so that would be great. No judgment, trust me, on my end, but I would love to touch base with you. That concludes our notes for part 1 and 2 for stoichiometry.